the heating effect of electrical current and the concept of electric power. In daily life, we see that whenever we run an electrical appliance, it gets warm or hot. The heat that we observe is often wasted heat, since we do not desire for the device to become hot. For example, a fan or a motor. In some other cases, a large amount of heat being generated may actually be useful, for example, in a water heater. But be that as it may, all these devices are demonstrating the same effect, the heating effect of electrical current. Let's see what is going on here. Let's say that we have a circuit with a potential difference V between the points A and B. The power source must perform some work to move a charge Q from A to B. Let's say a current I is flowing between the points A and B due to a potential difference V. If work is equal to voltage multiplied by charge or V multiplied by Q, the work is done in time t. Then the power of the circuit is equal to work done divided by time. That would be equal to V multiplied by Q divided by t. We already know that Q upon T, that is charge per unit time, is current. So we get a new expression V multiplied by I. Since energy is power multiplied by time and power is equal to V multiplied by I, the total energy expended in this circuit to move this charge from point A to point B is V multiplied by I multiplied by T. But in an ohmic circuit, that is any circuit that obeys Ohm's law, we know that V is equal to I multiplied by R. Substituting this value in the above equation, we have H equal to I multiplied by R multiplied again by I multiplied by T, or H is equal to I square R T. This is the mathematical expression of Joule's law of heating. So what are some practical applications of electrical heating? Every time you use an electrical heater to boil water, you are using the heating effect of current. Every time we use an incandescent bulb to generate light, we are using the heating effect of current. The filament of an electrical bulb is made from a material like tungsten. Tungsten has high resistance for a metal and also extremely high melting points. In fact, you cannot melt tungsten in a conventional furnace. It is that high. So when you send a current through this filament, the high resistance and the high voltage being supplied causes a large current, and this current has a very high heating effect. The filament is heated to a very high temperature and glows white hot, which gives the heat to us and the light. For lighting purposes, an incandescent lamp is rather inefficient. Actually, 80% of the energy is being expended as heat and 20% as light. So if you are using it to produce light, it is a very bad application. On the other hand, an LED, which is generating a lot of light, generates much less heat. This is because the resistance of an LED is much lower. A brief note on the measurement of electrical power and electrical energy. We just saw that electrical power in a circuit can be determined as the product of the voltage of the circuit and the current flowing through it. In other words, electrical power is equal to V multiplied by I. So if we multiply 1 volt with 1 ampere, we get 1 volt ampere or 1 watt of electrical power. This is the standard unit for power. Unfortunately, it is also very impractical because most applications require significantly greater amounts of power, especially in commercial use. So we have come up with an alternative commercial unit for this purpose called the kilowatt hour. A kilowatt is 1000 watts or 1000 joules per second. And when we say kilowatt hour, we simply mean multiplying 1000 watts with 1 hour. An hour contains 3600 seconds. So 1000 watts is equal to 1000 joules per second, and if we multiply this with 3600 seconds, the seconds cancel out and you are left with a figure of 3.6 multiplied with 10 to the power 6 joules. This amount of energy is called 1 kilowatt hour or 1 unit of commercial energy. So next time your parents say that we have spent 12 units of energy in this month, they are actually telling you that we have used 12 kilowatt hour of electrical energy.